name is Liddament. I work at Bristol. That's our office in there, if you're wondering. And I'm going to talk about beyond unit testing. First of all, very quickly, why test at all? There's the obvious ones, is to make sure that everything is still working. And we've kind of learned from Dan's talk the benefits of the value of doing unit testing, or doing any kind of testing even. Testing does validate that the code we've written actually works. It's also quite handy to happen. Normally what happens is we're kind of developing our software incrementally. So if we have tests at each stage of our development, then when we add new features, we can check that the old features haven't broken. So it's quite good to have some kind of test suite to protect against regression when we add new features. So I kind of see testing as a bit of a continuum. So I'm going to just define these two terms, what I'll be using for this talk, because when it comes to testing, lots of people have different terms that kind of mean the same thing or different things to different people. So at this side, these are your unit tests, and by that I mean just a really simple bit of code that works in isolation, and when we are testing that, we're testing just that code on its own, and this code isn't collaborating with anything else, it's just there on its own. And then we've got something all the way at the other side, which are called system tests, and this is like our complete application. It's deployed, maybe on a staging server, and somebody's there, if it's a web app, clicking away, checking that everything works. And then we've kind of got all this stuff in between. And I'm only really focusing on, is the software functionally correct? I'm not really worried about load testing for this talk, or performance testing or usability. It's just, is the code performing in the way it is supposed to be doing? And this kind of center ground, people might call them integration tests, or functional tests, or component tests. People have lots of different names. I believe Google say this kind of stuff is our small test, and we've got medium tests, and then we've got a large test over here. So I'm not going to be too fussed about the names. What I am more interested in is kind of some of the properties of these things. So if we kind of think speed of test execution. So at the unit test level, these tests run really, really fast. As we move across, our testing is involving more and more of the system, so the tests generally run slower and slower and slower until we get to the system level where there's some guy there sitting away, clicking at the application, checking it's all working. So these are very slow tests to run. Then we've got speed of writing tests. You know, if we are just testing a little bit of code that works completely in isolation and has no dependencies on anything else, it is quite quick to test. As we go over there, we've got to worry about mocking and stubbing, and then eventually all the way at system tests, you know, you've got to say go and do this and then click on there and do that. You know, it's a lot longer to write like a formal test as we go that way along our testing continuum. How much can we automate? Again, at unit test level, everything. You can just basically use a tool like PHP unit, say all my tests are in this test directory, and it'll go, run all the tests it finds, and give you a report at the end saying that they've all passed or which ones have failed. Once you're all the way down here, this poor tester, system test, is just clicking away, and none of it is automated at all. And as you move over to here, you're kind of involving more systems and more bits of stuff that you have to have some kind of human intervention to do the testing for. And then kind of robustness. Again, if our code doesn't collaborate with anything else at all, it doesn't matter what's going on around it. Nothing will affect it. So we've got really robust tests here, and then as you go along to the system level, you know, you might have a test, and if something changes about one of the processes, that could break a lot of tests. So they go from like very robust to quite fragile. So that might lead us on to a question, if unit tests are so amazing, why even worry about anything else in unit tests? What I'm calling unit tests, they're so amazing. And the answer is you want to do as much testing as you can at this level because of all the benefits we've looked at. But there are some things that you just cannot test at this kind of unit test level, and we need to move over here to do that kind of testing. So if we have, how easy is that? Might not be very easy to read that. Can you read that roughly? Brilliant. This is like a really simple thing here. We've got a password validator. We give it a password. It returns true or false as to whether this password is valid. And our criteria are, it's got to be 8 or more characters, contains at least 1 digit, and at least 1 letter. This does not collaborate with anything else. So this is a pure unit test. We could write the code, we could do this in a TDD manner. You could probably get that done with all the tests you needed in about 5 minutes. It's a very simple thing that we're trying to run here. And we can have the test there forever, and we know that our password validator will always work. Now, imagine somebody comes along and says, well, we've got an extra requirement here, it's the stuff in orange. The password cannot be one of the user's previous 5 passwords. So we've got to kind of update the API a bit. We've got to, when we're saying, is this password valid, we also have to know which user we're talking about. So if we're thinking about this, and we're thinking about good OO design, our password validator, well, we're thinking about single responsibility principle. That means a class only should have 1 reason to change. So our password validator, that can change only if we're changing something about how we're validating passwords. So it's okay that it changes in this case because we have an extra requirement on how we're validating our passwords. But the password validator shouldn't really be caring about where we get this, the previous 5 user passwords. That is the responsibility of something else. So we're going to separate that out, and our password validator, our user password repository, so this is just an interface to something that will go and get the last 5 passwords that a user's got. So we can write more unit tests for both of these things, but we're kind of getting, our tests have kind of got a bit more complicated. We've got something over here where our tests were working completely in isolation, and we've taken a small step this way. So our password validator test now depends on another object, and we made it as decoupled as possible. We're just worried about the interface to it, not worried about how that other object works. But this test, we've gone for something that's completely in isolation. Now we have to worry, I called both of these things unit tests, but we have to now worry about mocking the user password repository. So our test has got a bit more complicated. They've also got a bit more fragile, because if something changes about the interface, the user password repository, then that will break our tests, and we'll have to go back and look at them. So we're slowly edging from this nice simple thing over there. So our tests got a bit more complicated. And if we're using unit tests, they might not even find some of the bugs we might have. We might be so focused on writing tests that check that our password validator doesn't allow you to use any of your previous 5 passwords. We could do something really stupid, like completely forget to write the code and test the code that actually stores a user's, every time they update their password, it stores that. Presumably we'll have to have a system which maybe stores that in a database or something. We could completely forget that code, just complete oversight. All our unit tests pass, but it's not going to work. When we get all the way down to our system level over here, it goes, well, hang on a minute, this test doesn't work. I can use the same password, I can update it any number, to a previous password. We might not do something that stupid, but there might be some other problem. We might overlook something critical. For example, if we're talking about passwords, we should really be storing them in databases as their hashed passwords, not their plain text passwords. But here I am writing my code, and I completely forget about that or something, and then suddenly I'm comparing plain text passwords with the hashed versions of passwords. So again, our code isn't going to work. And you might be thinking, well, that's a pretty silly example. Nobody's actually going to make those kind of mistakes. And you're probably right. But it kind of illustrates that the problems we have with just doing unit testing. And when you've got a bit of code over here that collaborates with a bit of code over there, unless, we can't, how do we know that this collaborates successfully with this code over here? And using unit tests alone, we don't. We have to do something more. So that kind of makes sense. It's a bit of a silly example, but that's just to illustrate the point. So how might we go beyond unit testing? If you are writing good unit tests anyway and following kind of good OO practices, you don't really have to do anything different. You're just applying the same principles you would be for sensible unit tests, just at a bigger level. I mean, I even use PHP units to run all my tests anywhere from the unit level, pretty much all the way over. Anything I automate, I pretty much use PHP unit for. There are other tools out there. The choice of tool, it doesn't really matter. Just use what works for you. But what does matter is we architect our code. We have good architecture for our code because that makes the testing a lot easier. So we're going to apply all the kind of OO principles that we should be applying really anyway. Things like single responsibility principle. Have loose coupling between our objects, design to interfaces and stuff like that. That will make our lives easier for when we want to. I mean, you kind of have to do that for unit tests anyway, but it'll make it easier beyond that. So let's have a quick look at what potentially a good architecture might look like. So this yellow box is our business logic, and that is kind of like this is all the logic that is specific to whatever problem we are trying to solve, and that will be composed of many classes, and they'll all be interacting with each other. And the important thing here is the business logic doesn't really care or know about anything that's going on outside of that yellow box. Okay, it doesn't really need to know anything about that. We're trying to keep it all in that yellow box there. And this is kind of also the area where we should be focusing most of our testing. When people are talking about code coverage and stuff like that, I would want my code coverage to be high in here because this is where our value really is. Anything around the outside, you're probably just ending up probably just testing the framework, and other people have already done tests for that. But in the real world, business logic will probably have to persist data probably to a database. So the business logic knows about things that persist data by the interface, but it doesn't really care how that is done. So coming back to our example from earlier, the user password repository, as far as the business logic is concerned, I just want something that gets me the recent user passwords. Whether you store that in a database or on a file somewhere, or whether you go to an API to get it, I don't really care. All I'm worried about here is getting me the last 5 passwords that user has had. And a similar principle that kind of applies to things that the business logic might want to talk to. So maybe it has to send email notifications. Maybe it has to talk to payment providers. Maybe it wants to send tweets for you or something like that. Again, all it really cares about is the interface to the external service, not how that is actually achieved. So, if we're going to send an email, it could be something as simple as this. Here's our email gateway interface, and just one method, send email. And we pass it this object, the email message, which we'll have a look at in a moment. That's how this actually gets implemented. Don't care about from a business logic perspective. So what might we put in the email message? It's just holding stuff that we'd actually want to send. So the stuff in white is all pretty obvious. To help us potentially with our testing, generally these days, if you're sending emails, it's a bit like making HTML pages. You say, I'm using this HTML template, and here's the data I want you to put in the template to send off this email to send off to whoever you want to send the email to. If we remember things like the template name, the data, this will help us later, as you'll see in our testing. So this is kind of, we are fudging our code slightly to help us with testing, but everything else is just good practice. And then finally, obviously we need to somehow talk to our business logic. So maybe we've got a command line interface, or probably it's some kind of web application, and essentially it is the controller here that is going to go and talk to the business logic. So the responsibility of the controller is, well, the responsibility of the framework or the controller is to process the HTTP request, get the data that we want from it, ask the business logic to do something with it, get the response back, and then convey that back to the user if it was a controller for a website. So we want sort of quite thin controllers, and we definitely do not want any kind of business logic in there because it all lives in the yellow box. So, you know, maybe a really, really thin controller is something as simple as this, where we're pulling the, whoever the authenticated user out is, we are getting the new password they want to update their password to, and then we're calling something called user service, update password, here's the user, here's the new password. And I've basically got, and then depending if that's successful or not, we'll handle either the success or the failure case. So again, just to really emphasize, there's no business logic here. It is just delegating this off. You can have, I generally use like a service layer, which is a thin layer, and it just acts as an interface to our business logic. And that's kind of, you know, that's just emphasizing the problem, the point here. There's no real logic going on in here. So that's our architecture that will help us with our testing. And you kind of would be doing all this kind of stuff at a lot smaller level if you're just doing unit testing, separating things out like this. So what changes would we make in our kind of test environment? As with unit testing, we would be giving fake implementations of things that are talking to external services. So during our tests, we don't really want to send emails. We don't really want to make payments. We don't really want to send tweets or whatever our business logic does. But we probably want to know what emails it would have sent, what payments it would have made, what tweets it might have sent. So we're going to put a stub implementation in there. And the stub implementation, it basically complies with the same interface, the email gateway interface, but it just doesn't send emails. So maybe this one, we have to have a send email method, but instead of sending the email, we'll just store that email message. And then we'll also have this find email scene, where we can pass in some criteria that we want to search for emails, because, you know, in a lot of tests, maybe lots of emails get sent, but our test is only interested in a little bit of that. So if we can search the emails quickly, say I'm only interested in emails sent to davidexample.com, I'm only interested in the ones which are the template register email, this helps us with our test later finding them. So this is a stub implementation that we could use, and we'll see how we use that later in our tests. Okay, so at the unit test level, we definitely wouldn't be interacting with the database. We would stub all that. But as we move along here, it might make sense to actually use talk to a real database, because it's a bit of a pain trying to stub a database, and actually they're pretty good. So in a lot of my tests in this intermediate range and beyond, I would probably use a real database. But there is still, we do want to get that database into a known state, either before we run the test suite or possibly even before we run each test. And this is why, you know, I was saying tests go really quick here and then they slow down and slow down. This is one of the reasons they kind of slow down, because we're now interacting with things like databases, and we've got to get them into a right state, into the correct state, so they're slowing down. Again, we know there's no business logic. We know there's no business logic in these things. So for a lot of our testing, we can just bypass them entirely, because these would just be talking to the service layer, so a lot of our tests can just talk straight to the service layer. So we're really focusing on what's going on in here, and we've kind of chopped out all these bits that'll slow us down. So now imagine we have gone back and we want to test the scenario where we have a user. They've signed up with one password, and then they change the password, and they want to attempt to change their password back to one they previously used. We need to know that that is not allowed, and we can't do that with unit testing. So how might we do it here? So again, this would probably be, abstract test case would probably extend some kind of PHP unit thing. And I'm kind of assuming here we are running, this could be a Symfony project, and Symfony gives us the ability, so Symfony, one of its things, and all the frameworks do this, they have a dependency injection container. So you can basically say to it, get me one of these classes, and it's responsible for instantiating it and resolving all the dependencies. So I'm saying, container, get my user service, and my user service is one of the service layers, which is an interface to the business logic, the yellow square. I'm going to get that user service, and then, the reason we're doing this, sorry, I forgot. We can't update somebody's password until we've registered a user. So we need to create a user first, and then we try and update their password. And this is another reason why, as we move away from unit tests, things get slower and slower, because to get the system into a state that we're okay for testing, we have to do a lot more setup than we would on unit tests. So that's another reason they run a bit slower. So yeah, the whole point of this is we're registering a user, and then once we've registered that user, we're then in a state ready to assert that our behavior is correct in terms of updating passwords. So we get our user service, we're going to register our user, davidexample.com, and remember, my initial password was first password. Whether that means we've got a good password validator, I'm not sure, because we probably shouldn't let things like that through. But anyway. And just for an added bit of complexity, let's say the user registration is pretty much like everything else. You register yourself, you then get sent an email, and then you have to click on a link, and only then are you properly registered on the system. So we need to simulate all that as well to get ourselves a registered user. So the next step is we are going to ask the container to get our email gateway. Again, we're in the test environment here, so we'll actually get our email gateway stub, the one we looked at a few slides ago. And here we are, we're going, okay, get me all the emails that are sent to davidexample.com, the person I signed up with, and they're using the template register user. Now, if we hadn't stored things like the template name, we could still probably go through all the emails, we could look at the subjects and go, oh, that probably was a registration email. But our tests would be a lot more fragile because the subject heading of an email might change. If you had internationalization, the subject heading might change. So it's just a lot easier to say, when we constructed that email, we know what template we use and we know what data we put in, so why don't we just save that data for testing? So here we can easily find my email, the email that should have been sent to me for registration. And we can just assert, this is a standard PHP unit thing, just assert that there's only one of them. And assuming that's all okay, we can then go and pull out the confirmation token from the registration email. So remember, we stored the data, so we can go and get the confirmation token. Again, if we were just dealing with the raw HTML email, we could go through and parse it and pull out the confirmation token, but that's a lot more effort. And we're not really interested in that here. So that we've got our confirmation token, and then finally we can complete the registration. So we'll go back to our user service, say confirm the user who's got this confirmation token. It goes off and does whatever magic it does in the business logic layer, and then it returns you the user that you've just basically registered. So now we're ready to test whether we can use a password that we previously set up. So the next step is, well, let's just update our password to something different, this time second password. We'll use the update password method on the business logic. It should be successful, so we're asserting that success is true. And now we're going to go back and try and update our password back to the first password we've had. So this is one of the original 5 that we're not allowed to go back to. So we call our user service. So I want to update the password for this user, and I want to go back to using first password. And we're asserting here that success is actually false. And providing that assertion is true, then we've kind of validated that that code is behaving correctly. And that's something we couldn't do just using what I'm calling unit tests just here. We have to move more into this kind of central intermediate ground to be able to do these kind of things. So this is pretty exciting, yeah? This is exciting. Right? We've basically written a test that sits somewhere between unit 1 and our system test. We can manage to validate the correct behavior, which we wouldn't have been able to do all the way over there at unit test level. We could do it all the way over here. We could have some manual tester checking that it all works. But it's a very expensive way of running that test. And we don't really need to do it. I think the big one here is it's all automated. Now we've written that test, it's automated. Every single time we run our test suite, this test gets run. That means if we are developing features in future and somebody does something which interferes with this, suddenly the test will fail. We could do this every time we push a commit up. We could have someone there clicking away, doing all the tests. But it's ridiculous. You'd never be able to afford that level of testing. And there's no need because we can automate it, as we've seen here. It's a hell of a lot faster than manual testing, Okay, there's a bit of effort in writing that test case, but once it's done, it's just paying back forever and ever and ever, you know. Yes, we've got this extra test. The test, you know, suite will run a bit slower, but Jenkins time or your CI tool time is a lot cheaper than a human's time. So, automated, a lot faster than manual testing. Also, the tests we've kind of done here are a lot closer to the acceptance criteria in our user stories, if we were using user stories, or our requirements. That if you're all the way down here at unit test level, it only really means anything to the developers. As we move across this way, the tests mean a lot more to people, you know, who maybe are speccing out the tool they want. So it's a lot easier to assert that our application that we're developing is performing in a way that people actually want it to do, rather than worrying about a load of unit tests, which are, you know, at the requirements level seem quite abstract, you know, seem quite, you know, detailed. We're not really worrying about that. Also, if it was easy to write this test, it probably means our code was reasonably well architected. If our code is reasonably well architected, then it probably means it's easy to extend and add in new features and stuff like that. So it is quite exciting, I think. You know, there we go. But those tests weren't amazing. That test we just looked at, the whole first page we were looking at was all just basically setting up, was all to do with basically registering a user. And that's probably the kind of activity, that task registering user, we're probably going to do that in a lot of tests, especially when you come into this kind of level, you know, almost system level testing. And there'll be lots of other tasks that will be similar to that. So what we really want to do is we kind of want to, you know, bunch together all these bits and just have like a bit of code for registering user, a bit of code for doing something else. And we want to do that for a number of reasons. The first one is so we're not repeating the same code in all our tests. But also, if we have a single place where we go through the user registration process, if something changes about how we register a user, we've only got to update the code in one place. So it makes, you know, as we're coming over here, naturally our code will become more fragile, our tests will become more fragile. And this is a way of protecting it and keeping our tests robust. Because if something changes about how we register a user, we just go in and change that common bit of code, and then all the other tests will still work, hopefully. And also, as we build up these chunks of code, it will help us write other tests a lot quicker. So we only have to go through the pain of writing the code that does a registration user once. And actually, I would probably write that at the same time I'm doing all the tests relating to registering users. So we could basically say, why don't we have all our little tasks, they can follow the command pattern. So they just basically follow this interface, and we've got an execute method, and we pass in the dependency injection, reference to the container, dependency injection container. And then our register user command can look a bit like this. We construct it, given the email and the password of the person we want to register. Then we've got our execute command, and this will basically have all the code we had a few slides ago that went through the process of registering a user. And if anything changes, it's only in there that we need to change it. And then finally, we've got this get user method, which will return the user we have registered. So if we revisit our test, what we had on the first page has been compressed into these 3 lines of code. Maybe register user command, execute it, and then get the user out. And then we can have the tests as they were before. So it's kind of a bit more clarity in what's going on in this test. I'm registering user, then I'm doing some test based on that user I've just created. And what I have found in testing is sometimes you're always running the same 2 or 3 commands together, so you can kind of make some super command that just runs each of the 3 individual ones. So that kind of helps us you know, making clean tests and robust tests, even when they're all the way over here, almost at system test level. Right. So, what we want to do, if we imagine our password validator thing, at the unit test level, we're probably going to do like 7 or 8 tests there. You know, is this a valid password? Is it too short? Is it missing a digit? Is it missing a number? You know, can we reuse the 6th password? Can we not? You know, will it tell us we can't use our 5th password? So we've got a lot of tests here at the unit test level. as we kind of move into this central ground, there's kind of 3 test cases we're interested. You know, we want to make sure that we can update our password if it's a valid one. We want to cover the case where we try and use a password that we previously used, was one of the previous 5, so we want to know that fails. And there's also a test where we just give an invalid password, you know, something that's too short. And by the time we get all the way over to the system level, because remember the interface just returns a true or false, either this password is valid or it isn't. All we're really interested here is 2 cases, you know, we've either supplied a valid password or we haven't. And are we communicating that properly with the user? So, we want lots and lots of tests at the unit level because that is the best place to run our tests. Not everything can be done at the unit level, so we have to do some here, and some we have to do all the way up at the system level. But what we want to try and do is we want to try and push further down the pyramid. So, you know, if we've got stuff at system level and we can actually move it down to this intermediate level, great. We've got stuff here and we can push it down to unit test. It makes our lives easier because these tests here are easier to write and they're quicker to run. So yeah, we want to push things as far down the testing pyramid as possible. So I'm just going to quickly go to our bonus slides. Can we automate anything else? Let's think about our email gateway. So we basically just stubbed out the email gateway and we used it in our test, our stub version. What if we want to test that email gateway really works? Well, what we could do is we can sort of help ourselves a bit with this kind of testing. We could write a little test wrapper, and what that does is that actually sends an email using the real email gateway code via the email gateway interface. You know, if you're using something like Symfony, you can basically make your own little command line things. Same in Laravel, I'm sure all the other frameworks do something similar as well. So we could run this command in Orange. We could say test email gateway, who we want to send the email to. And then it will use the actual email gateway to send an email. And it will also say, I am sending this email to me from this person. I'm CCing it to here. This is my subject heading, and this is the body. And there has to be some manual intervention here, because I have to check that email really arrived and it had all that information in it. And I can do similar kinds of these kind of little test scripts. You know, if I'm making a payment or interfacing with any other external system. And these little scripts would talk to the real implementation via whatever interface we've defined. So it means every time we go and do a release, we can run all these scripts and check that they all work as expected. So what we've done is we've automated as much as we can, because our system tester here, their time is relatively very expensive. So we want to minimize the amount of time they have to spend doing things. So we automate absolutely everything we possibly can. And the stuff we cannot completely automate, we do little things like this. Does that kind of make sense? Yeah, brilliant. Right, so those are our bonus slides. So in summary, often we will need to do more than just unit tests to test our functionality. We want to automate as much as we possibly can because, okay, there is some overhead in writing those tests to automate them, but once it's done, it's there forever. If you think about your architecture, it will be a lot easier to write these tests. And conversely, if you've got an architecture which is easy to write tests for, it is probably easy to extend your code, which inevitably you're going to do. And we want to push our testing down the pyramid. We don't want to be doing too much at this level if we can help it, because it's expensive. We want to push it down, down, and down to the unit level, if appropriate. And that's basically it. So I will put slides linked to that page. If you've got anything nice to say, put it on there. If you've got anything horrible to say, then talk to me in the pub later, please. Any questions about any of that? No, great. Still awake?
What name would you give the intermediate test that you were describing? That is not a unit test, it stops external systems, but it really speaks with the database and it really executes the chunk of code that is under the responsibility of the thing. I make this question because
Yeah.
in my Italian community we call them functional tests.
Yeah.
But while I speak here with people, it seems that functional test means something different.
Yeah.
I don't know how to call this thing that I know very well, but I don't know what's the
call
name of that level of.
So, I was kind of. This is why I didn't put that name on there, right? Because it appears like a lot of people. Like I've heard it called functional tests. I used to call that kind of stuff integration tests, and the reason I try not to give it a name is because if I say integration test and it means something completely different to who I'm talking to, we're going to have. It's a bit of a cop out not giving it a name, but you know. And also, you kind of get, as you're moving along to this centre ground, you get things where you kind of have, you know, if you say unit test doesn't talk to anything external, like a database from external service, you could have unit tests where, you know, it makes sense to stub, you know, your database if you're using the repository pattern. It makes sense to stub bits of it for what you're doing, but you could have a lot of objects collaborating with each other. And is that still unit test, or is that integration or functional? I don't know, is the answer, unfortunately. I can't answer that one. But, I mean, I call them integration.
This is, I think, a major problem because that we all have, it's
Yeah.
not about you at all. Because having a good idea of what are the boundaries of the thing that you are testing, so that you have a name like that if I'm debugging an integration test, I know what to expect. If I'm debugging a unit test, I know what to expect. And an end-to-end test, I know what to expect. I think before or late we will have to find a better definition for the problem, because it is also productivity and communication between people. Like we have brittle integrations tests, but we have good unit tests, or vice versa. It is a problem.
But even if you've got those defined things at the borders, you'll have this. Well, is it one of these? Is it unit or is it functional?
Yeah, you will have
You will always
a
have
gray
that
area.
there,
I agree,
yeah.
because opportunistically you could decide to go a step forward in a particular test, in a particular context, but at least to have, given the fact that there can be exception, to have categories that are more strict, I think would be good for the whole community.
Yes, it would help. I mean, I kind of think any level of automation is really the responsibility of a developer, because they have the best skill set to do this kind of stuff. And if you trust your developers to use the things more appropriately, you know, maybe if I'm reviewing a test, I go, why are we doing it all the way here? We can push it back down there. So yeah, I mean, yeah, we don't get too caught up on names. We just go, I think you can do that without these dependencies and stuff like that, because you know you'll be building up dependencies. I mean, I feel if you're talking to a database, it's definitely what I call an integration test or a functional test. But yeah, you still have this blur, I think. Fine.
With your example where you had the email during registration,
Yeah.
I like your idea of basically just taking the values, just name value pairs in there. I take it from that, the assumption of that test is that only half testing the output of the email. So you do the registration, you put in the name, you put the email into it, you send it, but it's not really sent, it's just sort of stored.
Yeah.
And then later on you test the name and email's present. But that's not really, it's only just sort of making sure half of it works, because you're not exactly testing things like, well, you know, this email is going to be HTML encoded, it's, the email client may see it as ASCII, when it's actually UTF-8, and then Microsoft Word decides it's going to do something really strange with it.
Yeah.
Is that the sort of the thing of just not going all the way to the completion and just sort of accepting that you can't test it all?
So in that context there, I would have a number of tests about registration, and some of it, which is easy to automate, would address some of the things you've raised here. But in the context we were using it here, we were like, I've assumed that there's some other tests which test for that registration user. So I just want to register my user, and I don't really care, you know, as long as I've got the bare minimum for the user registration, that's fine. And if I put any more testing in that part there, then it makes it a bit more fragile, because the real place you should be testing my user registration and do all my yours look like are in the user registration bit, not somewhere else, which is just depending on it. The other thing you can do is, I mean, it depends how many emails your system sends, but you could have a script that basically produces one of every single email that the email sends, and that's probably a sensible thing to do anyway. So when you've got that thing that just says, you know, send email, it would actually send, you know, if there's like 10 or 15 different types of emails you send, it could send you all 15 of them, and then it's just manually, okay, I'm going to look at this in this. Yeah, there will always have to be some human bit of it, and for stuff like, does the email look nice? You know, it is going to be down to humans to have a look at that, I think. But yeah, you do as much as you can to make that task easy.
So you're just keeping your test. You're only half doing it. You're not testing everything.
Yeah.
Take
Exactly, and also the registration stuff. There would probably be many tests to do with that, and some of them would be checking, you know, have I only actually sent one email? You know, have I sent some other spurious ones? I want to make sure I haven't. So, but that would all be in the register user bit of element of testing. Right then. If there are no further questions, I'll hand back to Tom, and he can tell us how best to get to the pub.